Is it visible to you?
Yes, sir.
Okay, now we'll see the next content, that's paints. Five paints based on material of construction and two points. Like ends of pipes are classified like ends. Second one is the plain ends, and third is the screw ends, and is ends. And fifth, spigot or socket ends. And we have studied a few ends in workshop. Here, first bevel ends. See the plain ends and the bevel ends. So in bevel ends, the ends are specified when pipe to pipe and or pipe to fittings. Joints are done by fillet welding. So here, with the help of fillet weldings, can use the plain ends when pipe to pipe or pipe to fitting joints are done by fillet weldings. First one is this is another is the threaded ends. In threaded ends, see bevel ends, threaded ends, flange ends, spigot or socket ends, and bevel ends. In bevel ends, when pipe to pipe or pipe to fitting joints are done by butt welding. See, the first one is plain ends, it is done by fillet welding, and now bevel ends is done by butt weldings. And third one is the screw joints, or we call the screw ends. When pipe to pipe or pipe to fitting joints are done by threaded connections. See here the threaded connections. So the help of screw joints or screw ends. Here we can connect the pipe to pipe or pipe to fittings are done by threaded connections. Now next one is a flange ends. In flange ends, provide bolted connection between pipes and between pipes and fittings. We can connect pipe to pipe or we can connect pipe to fittings with the help of bolted connection. That kind of connections or ends we call the flange ends. Now next is spigot or socket ends. When lead cloth or cemented joints are provided between pipes and fittings, then spigot or socket ends are used. Connect pipes and between pipes and fittings. And next is buttress ends. So buttress ends are used in glass pipings and are joined by bolting with the use of backing flange. Can connect the pipes with the help of buttress ends. While size is an important factor when choosing the flanges, means here if you see the different kind of flanges. So for this, we have to consider the important factor that is size. When we are selecting the flanges, elbows, and other piping components, piping process. Piping ends are critical consideration to ensure a proper fit, a tight seal, and optimal performance. So, the help of these piping fitting elements and to ensure proper fit, tight seals, and optimal performance. Based on that, we can select the different pipe ends. So here you can see the 3D sketches of pipe ends. First one is a plain ends, second one is a threaded ends, and next is a bevel ends. So that kind of ends we are used in piping industries. And the type of pipe ends chosen will determine how it connects to other components and which applications and components the pipe is best suited for. So here, plain ends, threaded ends, bevel ends are we are studied in mechanical workshops. There is a grooved mechanical joints or grooved ends. Means here, see the single pipe can also have multiple end types. See the plain ends. You consider the single pipe have also multiple end types. This is often designated in the pipe description or labels. For an instance, if you consider 3 by 4 inch having a schedule that is a wall thickness ATA or SA3A2 or TP316H. So it is threaded on one end and is a plane on the other end. So in contrast, if you consider 3 by 4 inch having schedule ATS, that is pipe has threads on both ends. Therefore, to consider the plane ends, feature ends typically cut at 90-degree angle with the pipe run for a flat or even terminations. In most cases, the plain end pipes are used in combination with slip-on flanges. So there is a type of flange, slip-on flanges, and socket weight fittings and flanges. Both styles required fillet weldings, either one or both sides of the fitting or flange, and at the base of the fitting or flange. Where applicable, the plain end will be placed typically 1 upon 8 inch from where the pipe rests to allow for thermal expansion during welding. This makes them ideal for small diameter piping systems. So for this purpose, we can use plain ends. Now next is threaded ends. In threaded ends, the nominal size of 3 inch or even smaller threaded end allow for excellent seal. Most pipes use the National Pipe Threads that is called as NPT standards, which describes the taper threads used on both sides with most common taper measuring 3 or 4 inch per foot. That kind of size configurations are used in threaded end pipes, and this taper allows the thread to pull tight and create more effective seal. However, connecting the threads on a threaded pipe properly is essential to avoid damaging pipes, fittings, or flanges. Improper assembly or disassembly may lead to seizing or galling. So that kind of disadvantage we arise when we use for a threaded ends. Once unseized, damage to threads or pipe could further reduce corrosion resistance and hygienic properties. Two popular reason for choosing stainless steel pipes. So for this reason, we can select the stainless steel pipe. This is called as SS pipe. Fortunately, avoiding this concern is often as simple as preparing the threads before assembly. Now we recommend the stainless steel thread sealing tapes. So here we can impregnate it with nickel powders. The tape keeps the surface of the male and female threads end separately. You see the threads. So here we can keep the nickel powders, the both surface of the male and female thread ends, while also lubricating the connections for easier assembly and disassemblies. Now next thread is bevel end. So use with butt weldings. So might be a study different types of weldings in workshop technology. So here bevel ends use with butt weldings. So butt welding here pipe bevel end pipe fittings commonly feature is 37.5-degree bevel. These bevel are often applied hand or through automated process to ensure consistency. This allows perfect match with bevel pipe fittings and flanges and easier weldings. So for this purpose, we can use the bevel ends. Now here you can see the butt weld pipe joints. So the pipe. So here weld. So we can consider the 37.5 the bevel welds. So here we can connect the two pipes. Here is a one pipe on the right side, another pipe. So with the help of this butt weld, we can connect these two pipes. And using the advantages of butt weld, so it is practically joining big bore pipings. Here, big bore piping means here uh, the dimension, the pipe is 3.5 inch, and butt weld for so we can avoid the leaks that we are considered the butt weld pipe joints. And that kind of joints easily radiograph. So why we radiograph? So we can see the pipe connections at the time of matching two pipes with the help of butt weld. So we can easily see with the help of a radiographic system. So there is a any leak. If there is no leak, then we call it is a reliable for leak. Therefore, it is called as a reliable approved joints. And then what are the disadvantages of butt weld pipe joints? Weld intrusion will affect the flow. See, while welding, so if there is an intrusion of words, then it will affect on the flow. And next is here end preparation is necessary. We have prepared uh, the pipes before welding. So here to perform chemical and to clean the surface or ends of the pipes. Means here we can use the acetone as a chemical, and with the help of this chemical we can clean the ends and then can perform the butt weld pipe joints. Now next is socket weld pipe joints. The help of socket weld pipe joints, here we can weld the pipes. Here first one is a plain, and here we are considered bore to schedule wall thickness. That is 80 of schedule is 160. That is a wall thickness. And here we can consider the expansion, the joint, so that we can avoid the thermal stresses when we consider the socket weld pipe joints. And once we weld with the help of socket weld joint, so then we can easily alignment than butt weldings. See the difference between the butt weld and socket weld pipe joints. So socket weld pipe joints easier alignment than butt weldings. And no weld here. First one is a next advantage, no weld metal intrusion into the the pipes. It means it will not affect on the flow in piping industries. And second, you consider the disadvantage of butt weld and socket weld pipe joints. So here, minimum thickness, this pipe size, then to consider 1 over 16 inch convert into 1.5 millimeters. So we have to consider the races pocket. So here we see the races pockets and kind of creation of the pocket so that there is a pressure of the liquid. Then cannot permitted by the code if severe erosion or great corrosion is anticipated. So that kind of welds are used, socket weld pipe joints are used in chemical industry. This is the disadvantage of socket weld pipe joints. Now next is a screw pipe joints. So here with the help of screw pipe joints, we can easily dismantle that kind of pipe connections in piping industries. So here we can connect screw pipe joints easily at the sites. In plants, there is no required any kind of special equipments like butt weldings or socket weld joints. And here, weldings is not permitted due to fire hazards. So where welding is going, so we cannot use these screw pipe joints. And here, the joint may leak when not properly sealed. So if we are not joined properly, then leak will be arise in chemical industries and it's not permitted by codes. So if there is a severe corrosions or severe corrosions, shock and absorptions are anticipated. So in this case, we cannot use the screw pipe joints. If you are using the screw pipe joints, then pipe connections easily dismantle or easily here, strength of pipe is reduced as thread reduces the wall thickness, and seal welding may be required for these screwed pipe joints. And here, as per the course specification, that seal welding shall not be considered to contribute for the strength of joints. So that kind of disadvantage being cut while using the screwed pipe joints. Next is the flange pipe joint. So here, with the help of these two flanges and two pipes, we can easily connect with the help of bolts and nuts. So therefore, we can easily make this connection at the site. And that kind of pipe doesn't require any kind of weldings. So here, the material property of flange won't permit the weldings. And dismantling or disassemble a pipe connection is very simple as compared to earlier pipe joints. Here we have to remove the nut and bolts from the flanges and then we can easily dismantle the pipe systems. And disadvantages of flap joints. So there is a potential leakage if you are applying the flanges and connecting the two pipes. Sometimes, so here in this portion, this leakage will arise and even we cannot use when piping is subjected to bending moments so that the flange pipe joints are not used in high piping bending moments. So there is a more leakage. Now next is bigot socket pipe joints. So it can be easily made at sites. Can connect the two different pipes in the same or different dimensions in terms of diameter of pipes, or we can consider the nominal bore pipe size or nominal NPS, that is pressure size. So the NPS nominal size, we can connect the pipe joints. And here, with the help of socket joints, so misalignment can be acceptable up to 10 degrees, right? While connecting the pipe joints with the help of spigot socket pipe joints. And that kind of pipes are suitable only for low pressure applications. We cannot use for high pressure applications. So this is the disadvantages as spigot socket pipe joints. And this joint is required special configuration at pipe ends. So for this requirement, we cannot use spigot socket pipe joints in chemical industries. The next joint is buttress end pipe joints. So kind of joints are used in piping industries wherever we are used the glass pipings, and that kind of joints are not able to hold high pressure. So this is the limitations of buttress end pipe joints in piping industries. So are the common pipe abbreviations and standards. In standards, to refer the ASME B 31.3 for piping engineering and process engineering. So here in industry, so they are used some common abbreviations for the pipe ends. B stands for the bevel end, and next is a BBE stands for the bevel both ends. So for having the both ends, and BLE, that is a bevel large ends, and BOE stands for the bevel one end, and BSE stands for the bevel small ends, and BW stands for the butt weld ends. P stands for the plain end, and PBE stands for the plain both ends. In industry, there is no need to write uh, plain both ends. Simply, we have to write their particular abbreviations on drawing, where we are using the PBE means plain both ends, or POE as a plain one ends, TE that is a thread ends, and TBE that is thread both ends, and TLE thread large ends. And next one is a TOE, that is a thread one end, and TSE thread small end. So that kind of abbreviations are used for pipe ends in chemical industries, petrochemical industries, or hydrocarbon facilities. So that kind of abbreviation is very essential in piping industries. Whenever we are using the software like scissors, PDS, PDMS, that is a process design softwares, then we have to insert only their abbreviations of pipe end connections. And based on that, we can connect the pipes. Now next is types of pipes. So here types of pipes means based on the method of manufacture pipes. Then we can classify. The first one is a welded method of manufacture pipes. First one is a welded method. Now second one is seamless. In welded manufacturing pipe methods, so first one is a electric resistance welded. Might be heard this name in manufacturing technology or in workshops. So electric resistance welded, we call ERW. Pipes having longitudinal butt joint wherein Coalescence is produced by the heat obtained from resistance of the pipe. Resistance of the pipe to flow of electric current in a circuit of which the pipe is a part and by application of pressures. So we can use the electric resistance welded system. So we can weld the pipes. Now second method, that is a furnace butt welded or continuous welded. Pipes having longitudinal weld joints forged welded by mechanical pressure develop in passing the hot form and edge heated skull through round pass weld rolls. So that kind of process we can adopt for manufacturing the pipes, the help of welded methods. Now third is electric fusion welded. We call EFW. Pipes having longitudinal butt joints wherein coalescence is produced in the electric arc weldings or the produced in the performed tube by manuals. Weld may be single, double, the help of electric fusion weldings. Then we can manufacture the pipes. Now next is double submerged arc welded. So in double submerged arc welded pipes having longitudinal butt joint produced by at least two passes, one of which is on the inside of the pipe. Coherence is produced by hitting with an electric arc or arcs between the bare metals electrode or electrodes and the pipes. Pressure is not used and filler material is obtained from electrodes. So here in the double submerged arc welded, so pressure is not used. The filler material is obtained from the electrodes. So these are the welded manufacturing pipe methods for manufacturing the pipes. Now next is spiral welded. So in spiral welded, pipes having helical seam with either butt lap lock seam joint which is welded using either an electric resistance, electric fusion or double submerged arc welding process. In spiral welded, so we can use different methods to join the pipes: electric resistance, electric fusion, or double submerged arc welding process. Now next pipe, so we can use seamless, that kind of pipes for the high pressures. So with the help of seamless method, we can produce pipes by piercing a billet followed by rolling or drawing or both process. We can produce pipes with the help of seamless manufacturing method. So with the help of these two methods, so we can manufacture the types of pipes. First one is a welded pipes and second one is seamless pipes. So that kind of pipes are used in chemical industries, in petrochemical industries, in pharmaceutical industries, and um, hydrocarbon facilities where we are used. In this case, we can use different kind of piping systems. If we are considering the seamless pipes and we require high pressure, so in this case, can go for seamless pipes. Now, these are the pipe materials. Once we manufacture the pipes with the help of welded and seamless, as per the ASME standards and ASTME standards, we have to pick the materials ASTM A53. So with the help of these standards, so here we can consider welded and seamless steel, black and galvanized. So that kind of pipes, so we can use steel pipes, black and galvanized materials. Now ASTM A106. Here we can go for the seamless. Here the cast, that is CS pipes for high temperature service. So we can go for that kind of pipes. We have to consider the carbon steel pipes for the high temperature services. And third one is ASTM, that is American Scrap Testing of Materials A120. It's a black and hot deep zinc coated, so we call the galvanized welded and seamless pipe for ordinary use. If you consider ASTM A120, so we can use pipes for ordinary applications. So that means there is no high temperature, high pressures. In this case, we can use ASTM A120, means here pipe material that is a black and hot deep zinc coated, welded and seamless pipes. Now next one is ASTM A134. So here we can use the electric fusion welded steel plate pipes. And here size the greater than or equal to 16-inch, that is a nominal bore. Then and then we can use ASTM A134. So here we are performing the electric fusion welded on steel plate pipes. So therefore we required more than 60-inch size. MB stands for the nominal bore. And ASTM A135. So here we can use electric resistance welded pipes with the help of this standard, that is ASTM A135. If you are using A155, then there is a electric fusion welded steel pipe. That kind of pipes are used for high temperature service. And another standards we can see the A312. So here we can consider the seamless and welded authentic stainless steel pipes. So here can use both kind of pipes, seamless as well as welded authentic stainless steel pipes. So likewise, we can use different standards like A3 seamless and welded steel pipes, and for which application low temperature service. We consider the high temperature service for A335. So here seamless ferritic alloy steel pipes. So that kind of pipes are used for high temperature service. And next standard, that is A35A, is used for high temperature service, and here we can use the material with electric fusion welded authentic chrome nickel steel pipes for high temperature service. Now next standard, that is ASTM A369, use carbon and ferritic alloy steel, forged and poured for high temperature services. So these are the uh, applications for the high temperature services. First one is A335, A358, A369. So the standards are used for high temperature services with different materials. So here A369, so we can consider carbon and ferritic alloy steel, forged and bore for the high temperature services. And next standard, that is A376. So here we can use this standard for seamless authentic steel pipe for high temperature central station services in chemical industry. So that kind of standards are used in chemical industries, petrochemical industries, or hydrocarbon facilities, so that we can pick the relevant pipes and materials. So there is a large list of materials. So you can refer a piping handbook. Today I uploaded in classwork. So you go through this, you will get all standards, and you can see their properties, all materials as per the ASTM A358 or A369 or A376. Now, next parameter is a pressure design. So, with the help of ASME B31.3, the clause that is 301.11. So, with the help of this standard, so we can consider the minimum thickness of this pipe. Whenever we consider the thickness of straight pipe, the internal pressures. So here, to consider this standard ASME B31.3. So then to consider the minimum thickness of this pipe. So it's TM stands for the minimum thickness equals to T plus C. So here T is P into D, or 2 into in bracket SE plus PY. So here P stands for the internal design gauge pressure, PSI. PSI can convert kg per millimeter square, and D is outside diameter of pipe in inch, can convert into millimeter also. And S is allowable stress from appendix, means here through the piping design handbook from appendix A. So here appendix A1. So we can consider the value of S, that is allowable stress from appendix A1. So it is PSI or kg per centimeter square. Now next parameter is E. E is joint quality factors from table, and kind of tables are given in piping handbooks. From this table, we can easily select the value of joint quality factors. The next parameter is Y. So here, coefficient. Y is nothing but coefficient. So we can pick this value from ASME B31.3, the clause 304.11. With the help of this clause, so we can pick the coefficient value. And here C is C1 plus C2. C1 is nothing but corrosion allowances. So for carbon steels, we are considered 1.6 millimeter kind of corrosion allowances for CS. And for stainless steels, there is no corrosion allowances. Means C1 equals to 0. And C2 is depth of thread. So here can the data of threads, and once we calculated the thickness corrected, considered the millimeter tolerances, that is 12.5% as minimum thickness. So then with the help of this relation TM, TM stands for the minimum thickness, that is 8 or 7 into P or 2 into in bracket SE plus PY bracket close plus C1 bracket close plus C. At the end, we can calculate the thickness that is to be corrected considering the milli tolerance of 12.5% of minimum thickness. Next, session, we see examples and to calculate the thickness of straight pipes under internal pressures. So this is all about today's lectures, pipe ends and types of pipes, with the help of different manufacturing methods. We can manufacture the pipes. First one is a welded methods. Under the welded methods, we have seen the different combinations of weldings. And next one is a seamless. Later, we have discussed about the different standards, materials as per the ASTM standards, the American Society of Material Testings, and we can select different standards uh, like ASTM A33 or ASTM A312, and we can select the appropriate steel pipes and appropriate weldings, and then we can go for the low pressure application, high pressure application, high temperature and low temperatures considered in chemical industries or in petrochemical industries. So that kind of standards are used in chemical industries, and select the appropriate materials for the pipes, and then to design the pressure under internal pressures. So the help of this relation, so we can find out the different values of minimum field thickness. Now here you can note down this example, and later in next session we'll see the entire procedure how to calculate the thickness of pipe as per ASME B 31.3 and select the proper schedule, means wall thickness schedule. You can abbreviate, that is SCH. So here the 12-inch means 300 millimeter nominal bore pipes has an internal maximum operating pressure of 500 psij, as a pressure square inch gauge. That is 35 kg per meter square to G. So if you convert in this units, then you will get the 35 kg per centimeter. And temperature 675 degree Fahrenheit. So here temperature is given in Fahrenheit. So there is no need to convert into Celsius. If you want, then you can convert into Celsius, but in industries, let's refer the Fahrenheit scales. And the material of construction of the pipe is seamless. Here, carbon steel to ASTM A106 group B. So here the material of construction of the pipe is mentioned as per ASTM A06 group B and seamless carbon steel. The recommended corrosion allowances is, here corrosion allowances is recommended for this system is 1/8 inch, means 3 millimeters. And then we have to calculate the thickness of pipe as per ASME B 31.3 and select the proper schedule. When we are finding the thickness of the pipe as per this ASME 31.3, we will refer as standard values and we select the proper wall thickness. It's called as a schedule. So as per these standards, in solution you see all kinds of values as per the piping design handbooks, and we calculate the thickness of the pipe and we select the proper wall thickness or schedules. So this is all about today's lectures. Now, if you have any questions, any doubts, so you can ask your doubts or questions. Yes. Hello.
No, sir, no doubt.
Okay, fine. Then, so you see the piping handbook and go through this handbook, so you'll get ideas about all standards in piping industries or process industries. Okay, then next lecture we'll see the solution of this example.
Okay,
Then
sir.
we'll close this. Fine. Then we'll close this meet right now.
Thank you, sir.